Good morning, everyone. My name is Ruby. Today, I want to introduce ocean acidification impaired carp Virginia behavior. What is ocean acidification? Atmospheric carbon dioxide absorbed by the seawater to form carbonic acid. Then carbonic acid dissociates to form carbonate ions and hydrogen ions. As the concentration of hydrogen ions improves, the water becomes more acidic. From this figure, we can see the ocean surface pH are decreasing. So we find that the water becomes more acidic. What is the change of ocean surface pH? Ocean surface pH has decreased 0.1 point since 1800s. And is predicted to just another 0.1 to 0.4 units by end of century. This pH prediction for 2100s will cause a nearly 15% reduction in carbonate ion concentration of seawater and a decrease in calcium concentrate saturation states. What is the influence of ocean acidification? Ocean acidification is expected to have largely negative impact on bivalve species. This is bivalve species. What is the influence of ocean acidification? For example, carbon dioxide induced ocean acidification. Important estuarine predators such as mount carp, this is mount carp, stone carp, brown carp, prey upon oyster, this is oyster, directly and indirectly affecting oyster's pollution diamonds. Oyster responds to predators by increasing shell strength and decreasing resistance to predation. Rising carbon dioxide is increasing change on global ocean chemistry and the ecosystem, and driving square ocean acidification, which improves classification rates of many marine invertebrates, changing their sensitivity to predation. Ocean acidification may also impair an organism's ability to interpret environmental signals. This is marine invertebrates. What is the purpose of this research? To understand the effects of ocean acidification on behavioral and conceptive interaction between oyster and the moon carp. Oyster were rise with and without moon carp for 71 days at 3 PCO2 treatment. During a series of trials, we find that ocean acidification reduced hair holding time, hair consumption, and duration of unsuccessful predation tests. Growth conditions. Oyster will rise in the condition with 3 acidification levels and the 2 carp percent levels, include percent and absent. Moon carp will rise in the condition with 3 acidification levels, and the oyster and the moon carp will control hydro feeding rates. Every 2 days, oyster will provide 14 microliter per tank of outdoor blend, and the moon carps will provide 15 microgram dry weight of green shrimp. This is green shrimp. Good conditions. Control PCO2 is near more than PCO2. Moderate PCO2 is a perfect end-century PCO2. And the last one, high PCO2 is a level that higher than the highest PCO2 predicted to be experienced by this organism. PCO2 is partial pressure of CO2. It mixed gases in equilibrium with experimental seawaters. Calcite saturation state is the product of the concentration of calcium ions and the carbonate ions defined by solubility product. When calcine saturation state has a value under than 1, the calcine carbonate will dissolve, just like in the high PCO2 treatment in the figure. pH, the seawater pH was measured each other day with thermoscientific oil 2-star benchtop pH meter, like this one. This is pH meter in this research. And from this figure, in the paper, we can find calcite saturation state was highest in the control PCO2 treatment. pH was highest in the control PCO2 treatment, and the DIC was highest in the high PCO2 treatment. Video known as of behavioral. Each feeding travel was recorded to explore the impacts of ocean acidification on carp progenitor behavior. Video announced as of behavioral include general activity, agonistic behavior, pair holding time, and the number of predation attempts, and the time in unsuccessful predation attempts. First one, general activity. Defined as any movement of a cloud. Cloud is this. And the agonistic behavior is defined as physical confrontations and delay movements when in close proximity to each other during confrontations. Pair holding time includes any use of carp killer, this is carp killer to gasper and manipulate an oyster. Number of predation attempts defined as any continuous grasping contact. The last one time in unsuccessful predation attempts quantify how persistent carps were in attempting to consume oysters. Calcification rates. From this figure, we can see oyster calcification rates were lost in the high PCO2 treatment. And the control and the moderate PCO2 treatment was not significantly different from each other. Carp consumption of oyster. From this figure, we can find control PCO2 treatment was highest, and the high PCO2 treatment is lost. And the control and the high PCO2 were significantly different from each other. Pair holding time. Pair holding time was highest in the control PCO2 treatment and lowest in the high PCO2 treatment. And from this figure, we can find the control and the high PCO2 treatment was significantly different from each other. Time in unsuccessful predation attempts. There was a significant effect on acidification with moderate PCO2 treatment, reducing the mean duration of time in unsuccessful predation attempts by 86.4% compared with control PCO2 treatment. The interaction between carp presence and acidification and the mean effect of carp presence were not significant, but acidification did significantly influence calcification rates, consumption rates, pair holding time, and the time in unsuccessful predation attempts. Discussion. General activity, agonistic behavior, time of predation of attempts, did not different as a function of carp presence or acidification. And from this figure, we can find in the high PCO2 treatment, in the bottom of this figure, oyster consumption rates were lower, so we can find ocean acidification reduced moon carp predation on oyster. Conclusion: acidification reduced total predator holding of a prey, and a French time that predators spend unsuccessfully attempting to consume prey. This finding suggests that, although classification has a minimal effect on predators to locate prey, predators are less persistent when they attempt to consume prey under acidified conditions. Thank you for your listening.
Okay. 9 minutes 24 seconds. 10 minutes, sorry. 10 minutes 24 seconds. Okay, Q&A. Howard. Louis. Jenny. Wayne. Okay, starting from Howard.
What is DIC?
What is DIC?
DIC is the dissolved in organic carbon. In Chinese is 溶解态无机态。
Is that okay? Louis. Repeat.
What is the calcification red meat? This one. Calcification red meat is the bivalve species in the ocean. They can grow and the growth shore. This shore is the composition is calcium. And in this research, they use this way to quantify all classification rates. We are going and wasting, and this is right in the paper.
Okay. Jenny.
What is free handling time?
Free handling time induce any use of cups, killer to gastro and manipulate an oyster. To gastro and manipulate, you know, 操纵 an oyster.
Wayne.
How do you get this oyster and crab?
Or from this data,
Repeat.
how do we get this oyster and the green cup? From this paper, we get. I don't remember the precise set, but I know the set is not. Is in different, and in the river, they catch there and do this research. Paper has write the precise set, but I don't remember.
Volunteer. Any volunteer questions? Okay, Steven.
Can you go to slide 7? Can you explain what is environmental signals?
Environmental, like the signature or weather change or rainfall change, and they can attach to these environmental signals.
Any volunteer questions? Any? No? Okay, my turn. Okay. the first slides, they are, so you prepare a lot of material, but there are some details that needs to be taken care of. For example, when I look at the title, the first word I may have as an audience or as a college student is, what is impair? I don't know how many of you know these words because it's quite literally. 是很书写的英文。Ready? Andrew, here? Is Andrew here? I happen to catch one. Okay. Wait. What's impair? Oh, that's good. So some of you know what's impair. So impair is sort of like a damage. No, we usually say damage, but impair is more literary. So therefore, my recommendation next time is that you take your time to explain some of these words that your audience might have questions. So imagine you are them and what might be their question. Okay. And also, in another example, your conclusion. So, persistent. I wonder how many of you know these words. Right. Tim. Oh, sorry, I told you this already. Okay. Linda, what's persistent? Do you know that? Oh, that's good. So some of you know. But I will take time to explain these words a little bit. Okay. And then also during your presentation, it would be good if you can put that notes, not just your slides. Okay, and the good thing about her talk compared, because in this class we have so many ocean acidification talks, and then I think she's probably, she's probably the one which her way to explain these parameters satisfied. So she took her time to explain what's partial pressure of CO2, and then calcite saturation state, and actually her use of equations sort of explain many things. Yeah, and then she explained also the pH. However, considering the question of how I think maybe next time you also explain DIC, okay? So then you explain everything. Yeah. Okay. And then during the talk of is that next one here? Okay. Then you say the authors did video analysis of behavior, and then there are some general activity and agonistic, blah blah blah. And under this situation, if you want to make your talk more interesting, I would say usually I would use some images you can find from the internet to support your argument. Like for example, maybe general activity is prowling, passing, or something. Then agonistic behavior is probably they fight each other. I'm not sure. In that case, that will a picture is better than 1,000 words. You know. Mm-hmm. Okay, and then I also noticed that I'm not sure if that's true. Did you recolor the graph yourself? Okay, so in order to give you a very impressive idea about how the data look like, actually, these colors are made by herself. Yeah. And this is not very often seen in this class, but during the past few years, some students, they actually they recolor the black and white graph in the paper so that they are easier to read for the audience. And I also encourage that. So these are all color made by herself. Okay. However, probably you haven't noticed when introducing your results, you did not explain the axis. You went through the graphs very quickly. So all this data, blah, 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 that data, blah, blah, blah. Yeah, so it would be great. For example, what maybe you have explained is different PCO2, but the audience already forgot. So you should say these are different PCO2 treatments in the x-axis and what's y-axis. And usually the y-axis is difficult to understand. For example, this is a question I have for you. This graph, it says, time in unsuccessful predation attempts decrease with moderate PCO2 treatment. What does that really mean for the crab behavior? Can you explain in easy words? Is that good or bad? From here to here, you see it's a tremendous decrease, right? And it's the decrease in the duration of unsuccessful predation attempts. Okay, so if the unsuccessful predation attempts decreased, is that really good or really bad? Can you tell us? Bad? Why? Why is bad?
So, markup can protect oyster.
And
And is persistent or not.
okay, so if I were you, I would say they just tried a little bit and they gave up quickly. So it would be great if you can use easier words because persistent is a difficult word. So if you can say they just give a try and then gave up, then everybody understands it's not a good thing for the crowd. Okay, then the last point is I hope you don't take it offensive. I think in your talk I have the feeling there's extensive pronunciation problems. Yeah. For example, you say, how do you say this? Again? I think at some point you say moot crab. And then I was wondering what's moot crab. That's one example. And then another example is bivalve. Okay. So I wrote down several words, but I won't go through them. But later on, when I post your footage on the YouTube, I will give you a list of the words which you should check their pronunciation. Do you know how to check pronunciation of words? Okay. So I hope, because at least now you have PPT to help you. So even if we cannot understand your pronunciation, we can still look at the PPT. But you have to be aware that pronunciation is it's hindering a fluent communication with people. So if now today I talk to you, and then without any slides, and you have pronunciation problem, it's really a problem. I cannot really understand what you're talking. So if I tell you you have pronunciation problem, I hope you can really take it seriously and then try to correct on yourself. Okay, and I will give you a list. Okay, okay, thank you. Let's thank Uli again.